Welcome to The Explainer. Today we're unpacking a bit of invisible magic. We're going to dive into the intense, decades-long security arms race happening right now inside your pocket. I'm talking about your keyless entry fob. It's this everyday piece of tech we completely take for granted, but the science happening the second you walk up to your car, it is absolutely fascinating.
Okay, let's dive right into this. Because when you actually stop and think about the reality of what you're doing, it's kind of wild. You are unlocking a 2-ton machine through a solid brick wall from inside your house without any wires, without physically touching anything, all using a piece of technology smaller than a stick of gum. It just effortlessly bypasses solid steel, glass, and drywall. I mean, it sounds like science fiction, but it's literally just a regular Tuesday morning for most of us.
Which naturally brings us to this question. How does something so weak pull off something so impressive? The signal coming out of your key fob is literally weaker than a human whisper. It runs on this tiny, flat battery that has roughly the same power output as a hearing aid battery, and yet it commands your car from all the way across the street. I want to build a little suspense here, because once you understand how this weak little signal actually works, it's completely going to change how you look at your keys forever.
Now, what's really interesting here is the contrast. Your key fob isn't sending out a sound, and it's not shooting a beam of light like your TV remote does. What it's actually doing is emitting invisible radio waves. It is using pure electricity and magnetism, vibrating together and traveling through the air at the literal speed of light. These waves just pass right through solid objects, and yep, they're passing right through your body right now, too.
So let's break down exactly what's going on inside that little plastic shell. You've got a tiny chip and a battery, and that battery lasts for years because it barely sips any power. When you press unlock, that chip translates a digital message, which is really just a short string of numbers, into a radio wave. It does this by switching an electrical current on and off to create highly specific pulses of energy. It basically acts exactly like Morse code, pulsing thousands of times per second, sending out this omnidirectional transmission that spreads outward in every direction. It's exactly like ripples spreading across a pond when you throw a stone in.
And those ripples wash over everything in their path, including your car's antenna. Most cars in North America are constantly listening on a very specific frequency of 315 megahertz, while a lot of Europe and Asia use 433 megahertz. But here's the catch, and it's a big one. Your car isn't just listening for your specific fob. It's listening to everything, all the time. Every single radio signal in that frequency range, from your neighbor's garage door opener to a weather balloon flying overhead, because it hears literally every signal in the area. It sets up a massive vulnerability.
And that vulnerability kicks off a continuous high-stakes game of cat and mouse between automotive engineers and criminals. Back in the early 1980s, car remotes used a fixed signal. And honestly, it was hilariously easy to hack. Thieves would literally just sit in a parking lot, record your static radio signal, and replay it later to steal the car. By the 1990s, manufacturers fought back by inventing cryptographic rolling codes, which is a really elegant everyday engineering marvel. But today, modern times have brought the rise of relay attacks, exploiting the constant signals of our newer keyless vehicles. Let's look at how they defeated those 1980s hacks first. Enter the rolling code. You can think of this as a highly synchronized secret sequence guessing game. At the factory, your key and your car agree on a secret mathematical formula and a starting number. When you press the button, the fob runs its current number through that formula and spits out a brand new number. The car receives it, runs the exact same formula on its end, and if those new numbers match, boom, it unlocks. This was brilliant because it instantly killed those old-school recording hacks. And old code is dead the exact second it's used. If a thief tries to replay yesterday's code, the car just outright rejects it.
But wait, let's think about our everyday lives for a second here. What happens if you accidentally press the button in your pocket while you're sitting on your couch, totally out of range of your car? Your fob just calculated a new number and moved forward in the sequence, right? But your car didn't hear it. So, shouldn't they be out of sync forever? Shouldn't you essentially get permanently locked out of your own car?
Well, this is where a seriously clever engineering fix comes into play. The system doesn't demand a perfectly sequential, exact step-by-step match. It actually allows for a window, sometimes calculating up to 100 steps ahead in the sequence. So the car checks this massive window of acceptable future sequence matches. If it hears a valid number from the future, it automatically accepts it, catches up, and resyncs the whole system. And that is exactly why your key still perfectly unlocks your door, even after your dog has been sitting on it in the couch cushions all afternoon.
Now, to fully grasp the modern threat to this system, we have to ground ourselves in a little bit of physics. Have you ever wondered why your key works beautifully from across a massive open parking lot, but entirely fails when you're just a few spaces away inside a concrete parking garage? It's due to a phenomenon called signal attenuation.
Basically, radio waves lose energy the farther they travel, and they especially lose power when trying to pass through heavy objects like concrete and metal. Now, manufacturers can't just crank up the fob's power to push through the concrete because government regulations intentionally force that power to stay incredibly weak. They do this so your keys don't accidentally interfere with things like emergency or aviation communications. So this is an intentional weakness.
And you guessed it, that intentional weakness is exactly what criminals eventually figured out how to exploit. I want to slow down here for a second because this is the dark turn in our technological arms race, the relay attack. See, modern cars don't even require a button press anymore. They just constantly listen for a very short-range signal emitting from the key in your pocket. Criminals bridge this distance gap using two simple devices. One device captures the weak signal from your key, which might just be sitting on the kitchen counter inside your house. The second device, held by someone in your driveway, relays that boosted signal directly to your car. The car unlocks and starts, completely manipulated by distance. It totally bypasses the rolling code security because technically it is receiving a live valid code.
And honestly, here is the most terrifying part of all this. We are not talking about highly classified million-dollar government spy gear here. These attacks are being pulled off with equipment costing less than $100, easily purchased right online. This is incredibly accessible technology threatening everyday car owners, and it's happening silently without a single alarm ever going off. So the crucial point is, how do you actually stop it? Security experts recommend a comically low-tech solution for this high-tech problem. Keep your keys in a metal box, or literally wrap them in aluminum foil. Seriously, you basically need to make a little tinfoil hat for your car keys. Doing this creates what's called a Faraday cage, named after a 19th century scientist. It's just basic physics. The metal completely traps the electromagnetic signals, blocking them from getting in or leaking out. It's actually the exact same microwave physics that keeps radiation safely trapped inside your microwave instead of, frying your entire kitchen. But thankfully, car manufacturers aren't just crossing their fingers and relying on us wrapping our keys in tinfoil every night. They are aggressively fighting back using an entirely different property of physics. They're rolling out ultra-wideband technology. This is the engineer's newest, most advanced weapon to secure keyless entry systems and completely shut down these relay attacks for good. Ultra-wideband is incredible because it operates with absolute, mind-blowing precision. It doesn't just ask for a matching mathematical code anymore. It actually measures the literal speed of light to calculate distance down to fractions of a nanosecond. By tracking radio waves at this microscopic level, the car can calculate, almost to the exact inch, how far away the physical key fob actually is. Let's look at how physics provides the ultimate alibi here. We know that radio waves travel at a fixed, completely unbreakable speed, the speed of light. The car measures the exact, precise travel time of the signal coming from the fob. If the thief tries to pull a relay attack, well, that relay equipment, no matter how lightning fast or expensive it is going to take a tiny, tiny fraction of extra time to capture, boost, and transmit the signal. The car instantly detects that minute timing discrepancy. It realizes the signal took too long, knows the key isn't actually standing right next to the door, and it just completely blocks access. And this brilliantly illustrates the massive evolution this technology has undergone. We have moved from the old, simple security question of asking, do you know the secret code, to the new, ultra-wideband question of asking, are you actually standing right here, right now? It is nearly a century of physics, starting from basic 1900s radio transmission, evolving into 1990s cryptography, and culminating in modern light-speed measurement. And all of that is packed into a cheap little piece of plastic sitting in your pocket right now. So the next time you press that little button, take a second to remember the incredible, invisible wave of energy rippling out from your hand. But also keep this in mind. This is an active security arms race. As ultra-wideband rolls out everywhere, you really have to ask yourself, when we finally close one loophole in physics, who is already out there looking for the next? Because in this invisible, high-stakes cat-and-mouse game between engineers and hackers, the game never truly ends.